In this video, we're going to take a look at adding and subtracting rational expressions with unlike denominators. So if you haven't seen the video on adding and subtracting with like denominators, you might want to go back and watch that video because that will help you understand what we're doing here with unlike denominators. So unlike denominators, it's the same type of concept with just adding fractions, just fractions. So 3 over 5 plus 1 over 7, we'd want to find that LCD. So the LCD between 5 and 7 would be 35. Because 5 goes into 35, 7 goes into 35. That's the smallest number that they both go into. And then we'd have to manipulate both fractions. So what do I have to do to this fraction? I have to multiply by 7. What do I have to do to this fraction? I have to multiply by 5. So then that would be 21 over 7 times 5 is 35, plus 1 times 5 is 5, over 7 times 5 is 35. So then we have now the fraction with the same denominators of 35. So we add across the top, 21 plus 5 is 26 over 35. So we get 26 over 35. Same thing applies for something like this, 2x squared and 3x. I have to identify my LCD. The LCD here would be 2 and 3 both go into 6. Then x and x squared would just be x squared. So now I need to make them the same make them both have the appearance of 6x squared. So what do I need to multiply this fraction by? I need to multiply that by 3, because 3 times 2 is 6. And then this already has the x squared, so I don't need to multiply anything else other than the 3. Then this, what does this term need? This one needs a 2x, because 2 times 3 is 6. X times x is x squared. So whatever I do to the bottom, I do to the top. 3 times 3 is 9 over 6x squared. Plus 5 times 2x is 10x over 6x squared. Now the denominators are the same, so I'm going to add across the top. 9 plus 10x over 6x squared. And then I can't do anything from there. So that's the concept. That's what we're doing with rational expressions. You want to find that LCD, you want to manipulate the fractions, and then you want to perform addition, subtraction across the top. So let's look at number 1. So I have the denominator of x plus 1, then I have the denominator of 5x plus 5. So don't think like, oh, I have this denominator of 5x plus 5, therefore I need to multiply this by 5x plus 5. You can't think like that. You want to factor, if possible, everything. So this is going to stay 6 over x plus 1 plus then 15 over, then I could factor out a 5 and make this x plus 1. So 5 times x plus 1. So then from here, what I could do is you could actually, there's two ways of thinking about this, but I'm going to go the route of just making the fractions the same. If you see something else, have at it. But I'm going to just pretend like I'm not noticing something. So I'm going to find the LCD. That means that this would be LCD of 5 times x plus 1. Because this has a factor of 5. So they both need a factor of 5. Then they both already have that factor of x plus 1. So what does this fraction need? This fraction needs the factor of 5. Whatever I do to the bottom, I do to the top. And this one already has that factor of 5. So 5 times 6 is 30 over 5 times x plus 1 plus 15 over 5 times x plus 1. So then now we have the same denominators. So I'm going to add across the top 30 plus 45, or 30 plus 15 is 45. 45 over 5 times x plus 1. 45 divided by 5 is 9 over x plus 1, because I could simplify that. 5 goes into 5 one time, 5 goes into 45 9 times. And what I was saying before about if you are noticing something, go for it, is right here. When I factor out that 5 goes into 5 once, 5 goes into 15 3 times. 6 plus 3 is 9, because I already have the same denominators, but I wanted to just be consistent with what we're talking about. So number 2, what can we do on that one? Well, we have the factor of x plus 5. We have a difference of 2 squares, so let's factor the difference of 2 squares. So 6 over x plus 5 minus 5x over, difference of 2 squares is x minus 5, x plus 5. From here, we want to identify the LCD. So I have a factor of x plus 5 And this one, the second fraction here doesn't need anything because they both have the x plus 5, so we're good there. And then the x minus 5, though, this has a factor of an x minus 5. So the LCD is going to be x plus 5 times x minus 5. This first fraction does not have that factor of x minus 5. So that means I want to multiply by the x minus 5, both top and bottom by x minus 5. So I'm going to multiply the top by x minus 5. The second fraction doesn't need anything at all. So this is going to end up being 6 times x minus 5 minus 5x over the LCD of x minus 5 times x plus 5. So then now I'd have to distribute the 6 into here. 6 times x, 6 times negative 5. So 6 times x is 6x. 6 times negative 5 is negative 30 minus 5x over LCD x minus 5 times x plus 5. Now we combine like terms. So 6x minus 5x is 1x. 6 minus 5 is 1. So 1x minus 30 over x minus 5 times x plus 5. And nothing is going to simplify out. So that would be my answer after all of that legwork. So the key here is identifying that the denominator here is x squared minus 25. That's a difference of two squares, x minus 5 and x plus 5. So this fraction needed that factor of x minus 5 because this one already had both of those factors, where now that one needed an x minus 5. Good problem there. Let's take a look at the next one, number 3. 5 over 3x plus 4 over x plus 6. So what do we need here? So the LCD. We have a factor. There's no factoring. So we have a factor of 3x, and we have a factor of x plus 6. So each of the fractions need to be manipulated. So this first fraction needs the factor of x plus 6. Whatever I do to the bottom, I do to the top. This fraction needs the factor of 3x. So then we have 5 times x plus 6 over 3x times x plus 6 plus 4, and I probably should have just, you know what, yeah, I'm going to. I'm just going to make this all over the denominator of 3x times x plus 6. Plus 4 times 3x is 12x. Let me actually try not to take too many shortcuts here. So this is just 4 times 3x. All right, so I got the same denominator, and I don't multiply the denominator through. I don't do 3x times x plus 6 or anything like that. But now on top, we have 5 times x plus 6. So 5 times x, 5 times 6, 4 times 3x. 5 times x is 5x. 5 times 6 is 30. Plus 4 times 3x is 12x over 3x times x plus 6. So then now what can we do? We can combine like terms. 5x plus 12x is 17x plus 30 over 3x times x plus 6. And I don't have any sort of simplifying that I could do here because we just have that 17x plus 30, 3x times x plus 6, so nothing to simplify. So then that one would be done. All right, move on. So number 4, we have the denominator of x minus 5 and 5 minus x. Those are not the same. Positive x, negative x. Negative 5, positive 5. Those are not the same. Those are opposites. So we've talked about this before. Whenever there are opposites, we can use equivalent forms. We can manipulate them a little bit. So what we can do with the second fraction is you could factor out a negative. So this is going to be 7 over x minus 5. And then I take out a negative from here, and that becomes x minus 5 now. So I took out a negative, and that then flips the signs. 5 turns to a negative 5, negative x turns to a positive x. So then now I have this. So there's a couple different ways that you can do this. I'm trying to think of how I want to go about managing this. Yeah, let's just go with this route of... So I have this minus. So there's two ways you do this. You can multiply this one by negative 1. Let me just... Yeah, I'll just continue like that. All right, whatever. So then that's going to be negative x minus 5 plus 8. And so then that leaves us with negative 7 plus 8 is 1 over negative x minus 5. And you could rewrite that as negative 1 over x minus 5. So that's one way of just seeing, like, well, we have the x minus 5s. So all we need is just a negative 1 there. Another way of doing that is 7 over x minus 5. And then rewriting this as negative 8 over x minus 5. Just putting that negative like here when we factor that out, just putting it with the top. It's equivalent fractions. 7 plus negative 8 is negative 1 over x minus 5. You get the same thing. It's kind of two different methods there. It's up to you how that makes sense to you, whatever works best for you. But yeah, there's two ways of managing that. I was trying to figure out which method would be the most streamlined, most straightforward. And I actually think this one might be a little bit better. Okay, number 5, 3 over x plus 4. So the denominator here is 1. So if the denominator there is 1, that means the LCD is just x. So all that we need here is to multiply by x. So that's going to be 3 plus 4x over x. Because all I needed to do was just multiply by x, because this denominator was x. This was just a 1, so 1 times x. And then 3 plus 4x over x. These are not like terms. If this was 3x, then you'd have 7x. But that's just a 3 plus 4x. So I do not have any like terms. So then that one's done also. Moving along here. So number 6 is interesting because we have the denominator of x plus 8 and x plus 8 squared. So x plus 8 squared means that we have x plus 8 times x plus 8. So this is x plus 8 times x plus 8. So really, there are 2 x plus 8s. So my LCD is x plus 8 squared because this one has 2 of them. This one only has 1 of them, but this one has 2. So this one needs another. The first fraction needs another x plus 8. So that's going to be x plus 8 times 1, which is just going to be x plus 8. I'm not even going to write that out. Minus 7 over the denominator of x plus 8 squared. You could write it like that, or you could write x plus 8 times x plus 8, but we typically write it as just x plus 8 squared. So then x plus 8 minus 7. 8 minus 7 is 1. So we have x plus 1 over x plus 8 squared. Then I don't have any sort of simplifications that can be made. So I just have x plus 1 over x plus 8 squared. So yeah, key there is x plus 8 squared means x plus 8 times x plus 8. So this first fraction needed another factor of x plus 8. Number 7. The LCD is, we have a factor of x minus 7. We have a factor of x minus 3. So what does the first fraction need? The first fraction needs this factor of x minus 3. Second fraction needs a factor of x minus 7. So we're going to have 2x times x minus 3 minus, be careful here, I'm going to put this in like a bracket because I need, there's a lot that's going to go on here. So this is going to be minus x times x minus 7 because I'm multiplying this fraction by x minus 7, but I'm also subtracting it off. So I want to be careful on how I write that down. And then we're going to have the denominator of x minus 3, x minus 7. Let's just do a couple things here. Let's distribute the 2x. Let's distribute the x. And then keep in mind, I am subtracting off all of that second statement. So pay attention to that. So 2x times x is 2x squared. 2x times negative 3 is negative 6x. And then I'm going to leave this alone for a second. I'm just going to keep this in brackets. Let's do x times x is x squared. X times negative 7 is negative 7x. Over the denominator of x minus 3, x minus 7. Now, let's distribute the minus sign into there. And I've talked about this in previous videos. When we're subtracting off that entire fraction, I want to make sure you're distributing that minus. So we have 2x squared minus 6x minus x squared plus 7x all over x minus 3 times x minus 7. Let's combine like terms. What happens? 2x squared minus x squared is 1x squared, so x squared. Negative 6x plus 7x, negative 6 plus 7 is positive 1. So positive 1x over x minus 3, x minus 7. And there are some books, like if you're doing like homework problems or something, or looking at another textbook, some books will call this an answer, but we can also factor out an x from the top. But like I'm going to go over here. I'm getting a little close to my camera. I'm going to factor out an x, so that's x plus 1. And it's probably a good idea to get in the habit of doing that because there could be some sort of simplification that can be made. But in this case, there isn't. It's just x times x plus 1 over x minus 3 times x minus 7. No simplifications, but sometimes there would be like a factor that can cancel out like that. But there's nothing here in this case. This is a good problem. This is a problem that if you can get around this problem, then you should be in pretty good shape. In general, I mean, it's going to get more difficult than this, but there's a lot happening here. There's a lot of room for error, especially with this x times x times negative 7, while also keep in mind that we have to distribute the minus sign into there too. That's why I used the bracket there, just to have that visual of like, oh, I'm subtracting off that whole entire statement. All right, got a couple more problems here. So number 8, x over x squared minus 4 minus 7 over x squared minus 4x plus 4. So let's see. Let's factor everything. Just go through your factoring. So this is x over difference of two squares, x minus 2, x plus 2, minus 7 over, what is this going to factor to? Two numbers that multiply to positive 4, add to negative 4. That's going to be x minus 2, x minus 2. Negative 2 times negative 2 is positive 4. Negative 2 plus negative 2 is negative 4. So there we go. So this is going to be a tough one. We have the LCD. We have a factor of x minus 2, so they both have an x minus 2. This one has an x plus 2. So they both need the x plus 2. And then look at this. We have another factor of x minus 2. So that means the LCD is x minus 2 squared times x plus 2. They both need an x minus 2 because this one has two x minus 2s. This one only had one. So they both need another one. Or I'm sorry, I didn't mean to say they both need another one, but they both need two x minus 2s. So this one needs an x minus 2. Kind of out of room on this side. So I'm going to multiply by x minus 2. Whatever I do to the bottom, I do to the top. Then what does this fraction need? This fraction needs an x plus 2. So I'm going to multiply out this x plus 2. So let's see what happens. So on the top here, I'm going to do x times x times negative 2. So that's going to be x squared minus 2x. And then same thing as I said before. This is going to be 7 times x, 7 times 2, but we are subtracting that off. So I'm going to put that in parentheses, and then I'm going to do a separate step for that. So 7 times x is 7x. 7 times 2 is 14. All over the denominator of that massive LCD. So x minus 2 squared times x plus 2. Distribute the minus, so x squared minus 2x minus 7x minus 14 all over LCD. Now we can combine like terms right here in the middle. Negative 2x minus 7x is negative 5x, so x squared minus 5x minus 14 all over x minus 2 squared, x plus 2. Then we do generate a trinomial here where we can factor that. So let's just get in the habit of factoring, and then hopefully something will happen, something good can come from here. So I'm going to go over here. Two numbers that multiply to a negative 14 add up to a negative 5. That's going to be x minus 7, x plus 2 over the LCD of x minus 2 squared, x plus 2, and look at that. Look what happens. We have a cancellation. X plus 2 are going to cancel out, leaving us with x minus 7 over x minus 2 squared. You could write that as x minus 2 times x minus 2, but we do have a cancellation that could come from there with those x plus 2s. So cool, that's good. That's another one. Like these last couple problems, this problem and this problem we're about to do, and that last one that I did a second ago on number 7, like those are all really good problems to make sure that you can master, get around that every single step of the way, like being able to work with it, because it's going to be kind of interesting. My PDF messed up again. This is supposed to be 10. No, not 10. What is this supposed to be? I think this is supposed to be 12. Yeah, this is supposed to be 12. Okay. Sorry about that. My PDF did not copy over the number correctly. Yeah, it's supposed to be 12. So let's factor that. So 1 over two numbers that multiply to 12 add up to negative 7. That's going to be x minus 4 times x minus 3. Negative 4 times negative 3 is positive 12. Negative 4 plus negative 3 is negative 7. Minus 4 over x minus 4. It looks kind of bad. So now, identifying the LCD, that's going to be x minus 4 and x minus 3. So they both already have the x minus 4, so that's nice. But this one doesn't have the x minus 3, so we do need to multiply by the x minus 3 here. So we're going to have 1 minus 4 times x minus 3 over the LCD of x minus 4 times x minus 3. So let's distribute the negative 4. Negative 4 times x, negative 4 times negative 3. So 1 minus 4x plus 12. Negative 4 times negative 3 is positive 12 over x minus 4, x minus 3. So 1 plus 12 is 13. So we'll have negative 4x plus 13 over x minus 4, x minus 3. I'd be completely fine with that. There are some times in textbooks that will write it like that, and then they'll even have like an or. And what you could also do is you could factor out a negative from the top. So then that would become a positive 4x minus 13 over the LCD of x minus 4, x minus 3. But it's kind of like an or situation where both of those answers are correct, but there is an extra step there where you can factor out a negative, because you always want to factor out a leading negative, but it doesn't really do anything for us. It doesn't really lead us anywhere. So that's why both answers are completely acceptable. So this is a really tough lesson. I would make sure you can get around a problem like 9, 8, that other one, number 7 on the previous page. Make sure those are the types of problems that you want to spend a lot of time mastering.